I'd like you to change this first example. Change this to x equals 10, and let's include a y equals 1 equation. The example I gave you actually is not a good one. So 10, y equals 1. I'm going to ignore this area below y equals 1. Now, the way we have talked about finding areas, we are changing up our mindset of things. We are thinking of an integral, not as just like an integral means an area, but as an integral means an infinite sum. And we're taking infinite sum of rectangles. And I'd like you to not just like willy-nilly shade in a region, kind of like what I did. I want you to draw rectangles from left to right so that we can understand the heights of the rectangles and the widths of the rectangles. The widths are all just small changes in x. Widths are all dx. But tell me why, and discuss this with your neighbors, why can't we just use one integral for this situation? With or without an absolute value, I can't. I need two integrals no matter what. Why? Come on, everybody discuss. Oh. Our typical rectangle's height is a top minus a bottom, and the width is dx, right? What's the problem with the heights for this situation? What do you mean there's bounds for it? Sure. So what's that mean? What are going to be my two integrals? Tag. Switch. This is very important to see. The top changes. The top is y equals 5, and then these two things intersect at this location, and you know what? I'm going to use a different color starting from there because the top turns into the 10 over x. Do we see that? Yeah. If you don't draw your rectangles and if you don't think of it as a infinite sum, if you're not working from left to right, you probably missed that. And you can't miss that because it's very, very important to see, oh, what are my tops? What are my bottoms? Will they change? From 0 to this intersection ends up being 2. The top and the bottom is 5 minus 1. But then from 2 to what ends up being 10, the top minus bottom is 10 over x minus 1. Type that into your calculators real quick. You can get a numerical answer. We're going to reference that numerical answer in the future. I'll say new top minus bottom. You get 16.094. Right here. 0 to 2 of 5 minus 1, 2 to 10 of 10 over x minus 1, 16.094. Cool? Add them together. Boom. Cool. All right, well, we're not going to write them all out, and we're not going to find the specific values. But tell me, You tell your neighbor, how many integrals do you need in this situation? And discuss with your neighbors, the situation. If you're not sure, you should draw rectangles. You guys are not as talkative as you usually are. Start all the way from the left. Don't just shade randomly. Say, okay, here's the top minus bottom, top minus bottom, top minus bottom till here. So for my first integral in red, it looks like I'm going from -2 to some value. Don't worry about it. I don't want you to stress about it. The top is the e to the x plus 2. The bottom is 1. But then as I continue to draw vertical rectangles, I realize the top minus the bottom has switched. And now, from this second value to what looks like 1, the top minus bottom is 2 minus 1. And then if you continue to draw rectangles, top minus bottom, you realize it changes again. And it looks like it's from 1 to 2. It is, of 2 over x minus 1. Imagine trying to do all of those calculations by hand. That would be a lot of work, right? Now, even typing this into a calculator is like a little tedious and cumbersome. So, for situations like this, it's going to be advantageous to take an alternate approach to finding the area. Okay? We are stuck in vertical rectangle land. A vertical rectangle has got a height, that's a y distance, so y top minus a y bottom, and it's got a width. The width is a very small change in x. For these previous two situations, it will be advantageous for us to use horizontal rectangles.
It's probably a dumb question, but couldn't you also flip it upside down, or that'd be the same thing?
Same thing. And then you'd have to...
The bottom would be different.
Right. Different tops, different bottoms. Sometimes it'll be better to flip things on its side. Now, before we really understand what's going on here with these horizontal rectangles, let's make sure we understand what's going on with vertical rectangles. Okay? We are taking an infinite sum of areas of rectangles. What's the area formula of a rectangle? Base times height. I'm going to say it's a height times a width in this situation. What is always known in this H or this W if you are using a vertical rectangle? Discuss with your neighbor. What is always going to be consistent? If your rectangle is vertical, the width is always dx. It's a very small change in x. And to ensure the width is positive, what do you need to make sure you have in your integral? No, that will not ensure the width is positive. Left to right will ensure that we have a positive dx. If you went right to left and you use an absolute value around your height, well then all of a sudden you're going to have a negative answer even though you use an absolute value. Why? Because the dx would be negative. Okay? And then we talked about the heights as being a top minus a bottom. But it's important to think about where these top minus bottom equations come from. These are y distances, right? Now, maybe I don't really have a bottom here, but let's pretend we did. Let's like draw another curve, maybe. Like that. Okay, now let's focus on this rectangle right here. To find its distance, you need to take this y-coordinate and subtract this y-coordinate. This y-coordinate represents this distance from here to here. You subtract this y-coordinate, represents that distance, and you'll get it in between. So these are y distances that you are subtracting. However, Your y distances come from equations where you take an x-coordinate, you plug in that x-coordinate into the equation, it gives you a y-coordinate. Does that make sense? So top minus bottom, my thing just flipped off on me. Top minus bottom, this will be a y on the top minus a y on the bottom, but the y comes from equations of x's, you know, like an f of x minus a g of x. If this was f of x and this was g of x. Okay, switch things up. Now, we got rectangles on its side. We could say height times width again, but I'm not going to. I'm going to flip them up. I'm going to say width times height. Why? What is going to be consistent about all of these horizontal rectangles? The height, you guys are already on top of this. The height is a very, very small change. But it's not a very, very small change in x. It's a very, very small change in y. All of these rectangles, what's skinny about them? It's a skinny change in y. It's a skinny height. dy is now the height. And that will be consistent. Now, to ensure dx was positive, we went from left to right. And left to right were x-coordinates. That's an x-coordinate. That's our x-coordinate. Discuss with your neighbors. What do you think we'd have to do to ensure dy was positive? Bottom to top would be going up in a positive y direction. Very, very good, you guys, for being on top of this and thinking about this conceptually. Okay? These are going to be y coordinates. Now, let's pretend there was another curve. Say it looks like this. How can you find the widths? Okay, it's going to be a right minus left. It is an x distance. Let's pick on this one. This x coordinate minus this x coordinate. This first x coordinate gives me this distance. Subtract this distance. What's left over? That is the width. Okay? Now it's x coordinates. So here's the thing. What we are used to is having like x's in here. Y equals x equations. For here, we need x distances. We are going to need x equals y equations. We're going to have to sometimes solve our equations for x. So I understand what the x distance is in terms of a y coordinate. This is different. We haven't had to worry about this. But let's go and skip a bunch of examples, and we'll get to one that is kind of easy to see and understand. We go to this one. Okay, now this is an example where you don't have to use horizontal rectangles. It is actually not that advantageous to use horizontal rectangles. But I'm going to show you how you can get the same answer two different ways, and then we'll go back to ones where it is advantageous to use horizontal rectangles. Okay, so first, let's just make sure we understand vertical. If I use vertical rectangles, I'll just tell you on this question, they tell you that this intersecting point is at 9, 6. Tell your neighbor, what would be the integral that you would set up? You don't have to evaluate it, just set it up. Go. Okay, I heard a lot of people say 0 to 6. They're immediately wrong. Okay. Infinite sum, vertical rectangles, left to right, we're going from 0 to the x coordinate of 9. Okay? we are going 0 to 9, the top minus the bottom. Great. Good. Draw them so you know what you're thinking. Okay, now let's change our thought. Horizontal. Okay. Start it off. What's skinny about them? Y. To ensure Y is positive, I need to go from a bottom to a top. So we're talking about Y coordinates. Go ahead and fill in those coordinates. Now, here's where things are a little tricky, which makes this technique something that students don't like to use, but it really is very effective. We understand we got to go from a bottom to a top, so it's 0 to 6. This is a Y coordinate of 6. I need X distances. A lot of people say, oh, that's just this equation, 2 root X, and they put 2 root X in here. That's not correct. That'll give me a Y distance. That'll give me an up-down distance. I want an X distance in terms of a Y coordinate. I need to take this equation and solve it for X. Okay, go ahead and do that. When I take this equation and solve it for X, I get an inverse equation, but more importantly, I get an X equals Y, an X distance in terms of a Y coordinate. Divide by 2, I get Y over 2 equals root X. Square both sides, I get Y squared over 4 equals X. Notice, an X distance in terms of a Y coordinate. We got that? Y squared over 4. What? Do I need to subtract anything? I'm subtracting the left, which is a X distance of 0. So you might think right minus left. Well, in this case, yeah, no, there's no left. So I don't subtract 6. I don't subtract anything. You got to say right minus left. Okay, right minus left. Boom. Now, if I asked you to evaluate one of these two by hand, which one would you pick? Probably this one, actually. It's just one thing. I don't want to deal with the square root. I don't want to do x to the 3/2 times 2/3. I'd rather just do y cubed times 1/3. Regardless, type both of these into your calculator real quick. Oh, they're not going to be different. If they're different, then I failed. And so did you all. You all failed. They're going to be the exact same. We just found the same area 2 different ways. We get 18. Now, your calculator is even a little bit off on one of those. Right. The one with the root, your calculator is like, oof, I don't want to deal with that. So it doesn't get exactly on top of it. But we can see 18 is the answer. Now, my question is, how did you guys type in the y squared over 4 dy? Did you change your variable to y? No, you can just plug in x's. It'll get you the same answer. So if you freak out about the y's, just use x's. But we see these are the same. Okay? Now, for this situation, which way would you choose? I don't really care. For this situation here, change this to y equals x squared. You will see that one of the ways will only use one integral. The other way will use 2. So let me just sketch this shape, this region for you. We got y equals x squared. I changed it, please, to y equals x squared. 2 minus x looks like this. Here is my region. Y equals 0. I'll shade in the region, but I'm not going to like willy-nilly shade it just so you can see. This intersection is at 1, 1. We can find that, and you should be able to find that. And this intersection here is 2, 0. Discuss with your neighbors. Which way forces you to use two integrals? Discuss. Okay. Sketch your vertical rectangles very lightly because we're going to focus on the horizontal as well. Write down your integrals to get this area vertically. I recommend you just kind of throw some guys down and we see, okay, from 0 to 1, I got the x squared as the top. My bottom is 0. From 1 to 2, I have a new top, 2 minus x. And the bottom is still 0. Got it? Two integrals. That's a lot of antiderivatives and plugging in values. Or, let's see, would a horizontal rectangle approach give me a easier situation to maybe plug in or solve? So now, horizontal rectangles. I do see I have a right and a left, which is different from the last example where I did not have a left. I did not have to subtract anything. You guys figure out what goes in my integral using these horizontal rectangles. You will then be able to check your answers, plug the integrals we already wrote down into your calculator, plug in your other integral into your calculator, you should get the same answer. Please discuss with your neighbors. I want you all to try to get this. And you can also check, you know. Is this, okay, well, let's see. Looks like the answer is 0.83333, which is what, 5/6?
Oh,
It won't do it, right?
it won't.
Type in 5/6.
5/6?
Yeah. Yes, 5/6. The answer is 5/6. Okay, figure it out with your neighbors. What is this, what is our integral using horizontal rectangles? I know. Why? Because these are y distances in terms of x. I need an x distance in terms of a y coordinate. Whoa! There's a snake coming inside here. No. I think it's coming down from upstairs. I thought. It was just a snake was coming down from upstairs. Yeah. No. Listen, we've had raccoons fall through our ceiling before. Last year, raccoons were crawling up there, ended up falling into the lacrosse locker room. Yes, true story. That happened last year or 2 years. Oh yeah, it was like in the corner, and then they put it in a cage. Yeah.
There's a bad.
All right, here we go. From 0 to 1, that's this x coordinate, this y coordinate to this y coordinate. From a bottom to a top. It's not 0 to 2. Bottom to a top to ensure the heights dy are all positive. Bottom to top, the right minus left. Well, I need x distances. I need this x coordinate in terms of a y coordinate. I need to solve these equations for x to get this x distance in terms of a y coordinate. So I get root y is this x distance, and then I get 2 minus y. Ends up just being flip-flop, but the right is the 2 minus y, the left is the root y. Plug in either of these sets, this or this, you get the same answer. Okay? Now, pop up. to this guy. We didn't even bother writing down the actual integrals for this guy because there's 3 of them, including one really, really tough intersection with e to the x plus 2 and 2. It ends up being an x-coordinate of log 2 minus 2. Okay? Most of you would have been like, don't want to do that. So instead, I am just going to say you can easily write this area using horizontal rectangles with one integral instead of using 3, because there's one right and there's one left consistently versus 3 different top minus bottoms. Please write your integral for this example. And this is where horizontal rectangles will save the day. Solve your equations for x. You need x distances in terms of y. Yes, you do know how to do that. Don't tell me you don't know how to do that.
That is scrutiny.
What?
X equals 2 over y? Yeah.
Yes.
Okay.
That's the one we were having problems with? What about the other one? Okay, all right, well, that's good. So the e to the x plus 2 is 5. How do you do? Well, tell the people who are struggling with the other one.
You don't do anything. It's the same thing.
No, it's not the same thing.
Oh, wait, never mind. We're not.
How do you solve this equation for x? Take the log of both sides. Subtract 2. ln y minus 2 is correct. Yes. Now I'm really concerned. All right, we take the log of both sides. We get ln y equals x plus 2. We subtract 2. X equals ln y minus 2. That's this x distance. 2 over y is that x distance. We've solved both equations for x. We now have x distances in terms of y coordinates. Now, finish off your integral if you haven't done so already. This is it. Now, you have to plug that into your calculator. You don't know the antiderivative of log y. But does this make sense to us? How I did right minus left, but if you do right minus left, you need x equals y equations. So we have x distances in terms of a y coordinate. This is a very, very skinny height. We are making sure the height is positive by going from a bottom to a top. Okay, when you draw your rectangles, you can see, oh, my summing needs to start at 1 and go to 2. If you draw your rectangles, that will help you figure out these values that go here. Okay, good. I'm going to skip this previous one because when you solve for x, it becomes the same equation, and I think that confuses students. So we're going to just leave it at this. There are some situations you may see where they already give you x equals y equations. Well, it's just as easy as this. You don't have to worry about sketching anything. Like you could if you wanted to, but most of you will have difficulty sketching x equals y equations. Okay, let's pop back down. I got this region. We're back to this region. Okay? The bottom half says, find the line y equals k. That splits this region into 2 equal parts. This is a different situation than if I asked you for the line x equals k. Okay? Go ahead, discuss with your neighbors. What type of equation would you have to set up? Okay. If you tried to do this with vertical rectangles, you're going to really struggle. It doesn't make sense to do this, and then you got to switch it, and that's half of our area. It doesn't make sense also to do this because you don't know this hypothetical intersection. Okay, you don't know K yet, so you know where it's intersecting. There's ways for you to figure it out, actually, but it's actually more advantageous if we just say, well, horizontally from 0 to this line K, that's going to be equal to half of my area. We found the area was 5, 6, right? Now, again, since you are going from 0 to K, and these are horizontal rectangles with a skinny height, you need to make sure you have the correct expression for the x width, the x distances in terms of y. You need the y squared over 4, not the 6 minus 2 root x. This will equal half of the area we found, which was 5, 6. All right, solve. You can solve this without a calculator. Oh, was it 18? Oh, this one was 18? All right, so this is 9. Great. I thought it was the other example. You can do this without a calculator. Now, we've been doing everything. Put your calculator, Mr. Corey. We've been doing everything with a calculator, so we might have forgotten, oh, wait, to evaluate an integral, to get rid of this integral without a calculator, we have to take the antiderivative. We plug in k, we plug in 0. K is the cubed root of 9 times 12, whatever that might be. You forgot to take the antiderivative. Don't forget to take the antiderivative. If you need to evaluate an integral without the use of a calculator, which is what we need to do, you must take the antiderivative. Then plug in the top, plug in the bottom, subtract them. Then we can solve. Okay? All right. This was a pass-free response question. The cubed root of 9 times 12. That was the answer. Is that 9 times 12? Yeah. Cubed root of 108. We're not using our calculators. It's the cubed root of 108. Okay. Now, on this problem, part A is just find the area. They don't care how you do it. But then when you get to part C, they ask you for the line y equals k. This is much, much different than asking you for the x equals k line. They're asking you for a y equals k line. Go ahead, do part A. You can use your calculator, get your answer, check with your neighbor, see which way they did it. It's another one of those situations where doing one way, you are forced to do two integrals. Doing it another way, you can just use one. Now we actually have to find that intersection, so let's not waste too much time here. We find the intersection between log x and 5 minus x. And we get it 3.69. 34414 and 1.3065586. Okay, cool. We can either, using vertical rectangles, go from 0, I'll call this A, to A of my top minus the bottom is 0, and then add an integral from A to, this ends up being at 5, of a top minus bottom, which is 5 minus x dx. That's one way. Or, and this way will help you, the other way would help you if you were to answer correctly part C. Using horizontal rectangles, we'll go from 0 to this B of right minus left. This equation is x equals 5 minus y. That's the right. This equation is x equals e to the y. You have to take e to the power of both sides. That will give you the same answer as that. However, to find k easily, we need to set up this equation. 0 to k of 5 minus y minus e to the y, that's the right minus the left, dy equals 1/2, whatever my area is here. This says write but do not solve an equation. Great. We're done. You can say 0 to k of this, right minus left, equals k to 1.3065586. So it's like the area below the line equals the area above it. You can say the area below the line to overall area. Okay? So, listen. If we understand this, this will help us tremendously for next class. We understand this horizontal rectangle, the pictures, x distances in terms of y equations, y distances in terms of x equations. We are ready to start spinning these areas and finding volumes of three-dimensional objects created. Okay? That's what's in store for next class. Volumes of spun regions. Have a good one.